Good morning, everybody. Today we're going to be doing cross sections and solid rotations. So this is not a challenging assignment. Most of the questions will deal with you slicing a three-dimensional figure either vertically or horizontally and seeing what image is created. So basically, you could take a square, and or you could take a cube or a rectangular prism, and if you chop it either vertically or horizontally, you end up with a square or a rectangle. So a lot of the questions deal with cross sections. Now, cross sections are important in engineering, architecture, anything where you have to design something and you need to show a particular side view, top view, front view. So it comes into play in engineering and architecture, as I said. All right, so this is just a sample. Basically, you can cut any three-dimensional figure horizontally or vertically. Sometimes it's slanted too, but none of the questions are going to be set up for slanted. Okay, so basically, right here, if you slice this horizontally, you see what happens. It's a square. Now, if you sliced it vertically, it would also be a square. Okay, and right here you have a sphere, but when you slice it, it becomes a circle. So in essence, you could think of a three-dimensional figure as an arrangement of small, thinly sliced discs of circular discs that make up this sphere. Okay, so you can look at it that way. You can also look at this as a whole stack of business cards, or a stack of cardboard that were squares, and we stack them up vertically. We would have a prism. Okay, that's another way of thinking about it. All right, look at this one. So you see right here, there is a cylinder, but if we cut it horizontally, it creates a circular figure, as you see right there. So basically, all this is saying is that a cross section is a intersection of a plane and a three-dimensional figure. Okay, so that's basically what we just kind of went over. Okay, so moving along. Okay, so right here we have two more figures. Okay, so this one right here is a triangular prism, but as you can see, it's vertically sliced. So therefore, what would you notice? It is a triangle. But what if we cut this horizontally? Would we get a triangle? No, we would get a rectangle. Okay, now if you look at this last one, you have a pyramid right here. Okay, as you can see, it's cut horizontally. So what do you get when you cut it horizontally? You look at the little shaded area and you look to see what's created, okay? And you'll notice that it is a square. So that's the trick to solving this. You can look at the piece that's created, okay, in the center, as long as the shape is uniform, okay? And what I mean by uniform is that the way it starts is the way it ends, okay? All right, so as you can see right here, there's a triangle, there's a triangle. Right here, there is a square. So therefore, that is a square. Okay. All right. So the second part of the assignment deals with taking a figure and rotating it around an axis. Okay. So as you can see, we have a square right here, okay? It says a square with a perimeter of 36 units, okay? All right, the square is rotated about line K. So we have this square, it's 36 units and is rotated around line K. Okay, so there's line K right here. So if you rotate it, you'll see what you get. You get a cylinder. And then you notice at the base, what is a cylinder? It is a circle at the base. So what do they want to find? What is the circumference of the What is the circumference of the base when the square is rotated around line K? Okay, so if we rotate that, first things first, we realize that it's a square, a circle, which has a radius, right? And what other bit of information can we use? Well, it is a square, so that all the sides are the same. So if you want to find the sides of one individual side of the square, we just add them all up and set it equal to the total amount of the perimeter, which we have right here. So we have x plus x plus x plus x is equal to 36, and we add them all up, it's 4x equals 36. You divide by 4, you get x is 9. So what does that mean? That this length is 9 units, or in this case, 9 units. So this means that all we have to do is use our formula, circumference is equal to 2 pi r, which we have right here, 2 times pi times r, 9, you'll get 18 pi, and then if you compute that in your calculator, you'll get that to become 56.5 units squared. So this is very helpful. This is another aspect of of geometry that's used too. You can take a figure and rotate it around an axis. Okay, so I'm going to give you one more example of this, and that will conclude today's lesson. Okay, so you're only going to see about 2 questions like this. Okay, all right. This is it today. We have a equilateral triangle shown. Okay. Now, right here, if the equilateral triangle is shown above, and we have the key word is equilateral, which means all the sides are equal. And if that thing is rotated about the line A, so we have this line that it's rotated upon, they say, what is the approximate circumference of the base? So when we rotate it, as you can see, it becomes a circle again, right? But an equilateral means there's all these are what? The same. So this is 16, this is 16, the whole thing is 16, okay? So that means from here to here is 16, from there to there is 16, and from here to here is 16. Okay, so what you need to realize is that when you draw that line right here, we know that this is a 90-degree angle, and that's cutting it in half, right? Because if we said that these two are the same, let me see if you guys remember, if these two are the same, and this is 90 degrees, then you know that this is going to cut these two pieces into equal parts, right? So therefore, this being 16, you would cut it in half, and you'd know that's 8. And then therefore, 2 times pi times 8 would be equal to 50.2 millimeters squared. Okay, so it looks, these problems look challenging, but they're not really. You just have to realize what figure is being created when you rotate around an axis, and you'll realize that the only figure that's being created for the base, that is a square, because an axis, when you rotate around, a round surface is a square. Is a circle. A round surface would be a circle. Okay, so this is kind of like what the lesson is about. There are about 2 calculation questions. The rest are pretty basic, just understanding cross sections. So just take your time. You'll have 2 times to play. This will be due tomorrow afternoon at 5:15 p.m. Okay, I will be available from today probably until about 3 o'clock. If you ask me a question, you can ask me a question through Remind, and I will definitely be able to help you. Okay. All right. So this concludes the lesson for today. Good luck.